on in the background, just so that, and I think there's a way I can do it, but I can't figure it out. So welcome to today's webinar. And my name is Mitch Frumkin. Today we're going to be talking about winter concerns, ice damming, and more. And I would ask, we do a lot of webinars at Kipcon, as you know. And I would say if anybody has any questions while I'm going along, please feel free to use the chat function or use the chat function. Or the other thing you could do is to just jump in and unmute yourself and talk. And feel free to do that. Don't be shy. So if anybody has, let me get my screen up again. All right, so that's how we're going to go. We'll be done by 10:30, and there's a lot of information I've got to cover. So hold on, here we go. And again, my name is Mitch Frumkin. You'll see here that usually what I do is I tell all about myself, and but most people here know me. So I crossed all that out because for the first time ever, I'm looking, and I think my mother is here somewhere. And so the most important thing here is that I'm the son of Elaine, and she's here somewhere, I think. And tomorrow is her birthday. So my mother's birthday is tomorrow, and as her birthday present to me, she said she was coming to today's webinar. So I don't see her, but when she figures out how to work Zoom and you see Elaine Frumkin there, please feel free to jump in and say happy birthday to her. So what I'm going to be talking about is roofs. And I'm going to talk about the parts, how they work, winter problems, and for all of you out there that are looking for manager continuing education credits, this class is approved by CAI for continuation education units. So somewhere in the middle of the presentation, I'm going to give you a keyword. And that keyword is what you need to do. And it's if you just call our office or email to me or to Jolie or someone in the office with that keyword, then we'll send you the certificate for continuing education units. I'm going to talk about the causes, the symptoms, solutions. And, a lot of times people look at roofing problems in the winter and use the term generically as ice damming. What I'm going to talk about is it's more than just ice damming. Ice damming is just a term, but there's a lot of things that go on with the roofs in the winter that cause problems. So that's why I call it winter problems and ice damming and more. But the first thing I'd like to do is I'm going to ask you all, you should see on your screen a poll. So if you don't see the poll, please let me know, but you see the poll, it's 6 questions. If you wouldn't mind, I'm going to give you seconds to just jump in and answer these 7 questions so I can get a feel for the audience and everybody else can get a feel for the audience also. So can you guys see the poll? Mm-hmm. You do see it? Okay, good. I see that one person has answered out of 57. So we got another 56 to go. And the questions are just so are you a manager? Are you a board member? Have you ever experienced a roof leak in the winter? If you have a leak, was it caused by ice damming, condensation, or you're not sure? And then the next question, which you'll see that's part of the presentation, are you approaching the time to replace your roofs? What type of roof do you have? Do you have a sloped roof, like a shingle?
No, that's
roof?
it.
Or a flat roof?
You too, thank you.
And then the last question is the most important one. What season of the year do you like best? Is it winter? And winter's not coming in too high right now. Winter, summer, fall, or spring? So we'll give it another couple of seconds, and then I'll tell you the answers if you can't see them, and then we'll get going. And don't be shy, please feel free to fill it out. We're up to 39 out of 56 people have filled it out, and it looks like we're leveling off there. So, oh, here we go. I apologize if I made the questions too hard for you. Simple for early in the morning. And what I'll do is when we get in the next 30 seconds, I will end the poll. And the other, I'll say that somebody just texted me and said that they're hearing people in the background. So please, if you are talking, please feel free to do it, but I would ask that you mute yourself. Somebody says, I'm an attorney, the survey doesn't apply to me. Yeah, it applies to you, you're other. All right, so we've got 74% participated. I'm gonna end the poll and let's share the results with everybody. So you should be able to see that what we've got is 76% of the people attending today are managers. 12% are board members. 80% have had roof leaks in the winter. Very interesting. So you're at the right place, maybe. If you did have a leak, was it caused by 51% say ice damming, 12% say condensation, and 57% are not sure? Again, I'd ask if you wouldn't mind moving. Unless somebody's vacuuming over there. So ice damming, condensation, not sure. Are you approaching the time of year to replace your roofs? In the next 5 years, 76% of you. And you'll see that's important. A lot of things I'm going to talk about to correct the problems take place when you replace your roofs. What type of roofs you have? 51% are sloped roofs, and that's good because this presentation is related to sloped roofs. And 59% of people like summer. It's their best season. So thank you very much. And let's see. I'm going to go back to the presentation. All right. So the first thing I'm going to be talking about are the different parts of the roof. The different parts of the roof, because I think it's very important that for you to understand what the problems are, what causes them, and how to fix them, it's important to understand what the different parts of the roof are. So, and let's see. So what do you think the most important part is? There's a bunch of different things that make up the roof. There's all kinds of terms that you hear all day long. And a typical roof is made up of things like ridge, valley, gable, rake, fascia, eave, soffit. And so these are the terminology you use when you're dealing with roofs on a typical building like we're dealing with. Maybe it's a townhouse or whatever has a shingle type roof. These are the typical terms you use. When you're talking about problems in the winter due to ice and snow, it generally happens in the places where snow and ice can accumulate. So when you look at a picture like this, you see the valley, the ice can accumulate there and the snow can accumulate there. You see the sidewall. Sidewall is also a place, where there's a lot of leaks that take place at these sidewalls, and people group them in under ice damming. Then you have low pitch roofs where the water could sit there for a long time, the snow could sit there a long time, flat roofs, and all different parts of the roof that are, I'll be using some of these terms as I go through the presentation. But first, let's understand it. What's the most important thing? It's the roof shingles. And the roof shingles are exactly what they say. They're shingles, and you'll see that they're lapped one over each other. So you start at the bottom, you put on the next one, you put on the next one, you work your way up the roof. Now, why that's important is because when it rains, what happens is the water extends from the top to the bottom like this. And by the shingles lapping over themselves the way they do, and with the combination of water, rain, and gravity, your roof should not leak. You'll see here that I say on the bottom, these types of roofs are water resistant, not waterproof. And what I mean by that is, and you'll see in the presentation, that they're meant for the water to be traveling downhill. So if the water starts going up the roof rather than down the roof, what it does is it goes underneath the shingles. It goes underneath the shingles and then can get into the attics and get into the homes. So the roof shingles are the #1 defense against water. And I'll also mention that, people think that when they have ice damming problem on a roof or a problem on a roof that it may be a warranty issue. If you take a look at the warranties that come with shingle roofs, it's under normal weather conditions, which does not mean high wind. It does not mean ice and snow. It means rain coming down and gravity pulling it to the bottom of the roof. So #1 thing is the shingles. It's the top of the roof. So what's the next part of the roof? And by the way, I'll also mention that you see here, There's what's called at the bottom a drip edge. So there's a few other different things, but the main part of this is the roof shingles. It's now flashing. What is flashing? Now, flashing, it's a thin sheet of impervious material that is used to prevent water penetration into a building by directing the flow of the water out of the building, not into the building. So for example, if you look at the top picture here, a lot of you probably have that in your communities. You have a shingle roof that comes up against a wall and there's siding there, whether this is vinyl siding or aluminum siding or maybe hardy plank, whatever it is, that intersects the roof. And you see right in this area in here, right in there, I'm showing you red, that is the flashing. So in this case, it's a metal flashing. It's called step flashing. And now if you go to the picture right below it, you'll see that what it looks like without the siding on the building, the shingles, this step flashing goes up about 6 inches on the roof, on the wall, and it extends about 6 inches underneath the shingles. So that's one of the things I'm going to talk about. But just think that if the snow builds up against the wall and it's above the top of this step flashing, where does it go? But I also make a comment in here, without flashing, your roof or your building will leak. I would say the majority of cases we see with problems with buildings where they leak, it's because the flashing isn't done right, because a lot of people, believe it or not, don't understand the concept of gravity and water going down from the sky. So how does that happen? This is now the detail of what it looks like. Now to the left is how that flashing does work. So now what you're looking at is the bottom picture, and now you're looking at a little cross section of it. You have the step flashing, you have the shingles. And what you see on the left-hand side here is that there's house wrap, this black line that goes vertically. That's like the building paper, the Tyvek, you know, by a number of different names. Then you go down to the bottom, you have the sidewall flashing, which I pointed out, some people call it step flashing. Then you have the underlayment on the bottom. And the underlayment is like the roofing paper you see underneath the roof shingles. Again, it's similar to what you have on the wall, the Tyvek type thing. And it's an underlayment that goes underneath the shingles. Some people call these generic terms WRB, weather resistant barrier. And the reason it's called weather resistant barrier is because water does get behind the siding, water does get under the shingles, and much less under the shingles than the siding. And the concept is, how do you make sure that water that gets behind there gets out and not in? So the reason I say that is because now we look at the picture and you see the step flashing that comes up, is sidewall flashing. And then there's another type of flashing called counter flashing. This counter flashing goes behind the house wrap. So it's behind the house wrap. It comes out over the step flashing and it goes down. Why does it do that? So that if water gets through the siding is right here. If this water, which is the blue line, gets behind the siding, it follows the lapping of the siding and the paper and all kinds of things. So it comes down and is pushed out onto the shingles. So that's the basic concept of a good roof and good flashing in any event. Now, hard to believe, but what we see a lot of, and not just in roofs, but just about any part in a building, is what you see to the right. Now, what I've done is I've taken the exact same picture, but I've taken the house wrap, which is right here, and instead of having it come in front of this counter flashing, I have it go behind the counter flashing. So what happens is, now you see a red line. The water gets behind the siding. It travels down along this house wrap. But when it gets to this flashing, instead of going in front of it and coming out, it goes behind the flashing. And what does it do? It gets into your home. It gets into your attic or into your home. So this is the concept for flashing and why it is so critical, because there are so many people, roofers, that know how to put on shingles, but the concept of flashing and gravity in many instances is something that's totally lost on them. And you can't imagine how many times we've seen things, and I'm sure you've all seen things, in this audience, you've seen things where the water gets behind the flashing and the flashing is putting backwards. So it's pushing the water into the house rather than out of the house. So This is why flashing matters. It matters. It's the most critical part of the building because the flashing is what keeps the water out and it directs it out no matter where you are in the building, whether it's around a window, no matter where you are in the building. And you'll see why it comes in. It's so important when we're dealing with ice and snow on the roof also. What are the flashing materials? There's two basic types of flashing materials. There's an exposed flashing material, which is typically metal. You probably see it when you saw the picture back here, see it in here, this is a metal flashing. That's one very common type of flashing. The metal flashing, it's not a problem when that's exposed to the sunlight. It doesn't deteriorate if the sun beats on it. So metal flashing is used a lot, mainly in the homes where you have. Sorry, mainly, did somebody have a question?
It's calm. I can't get it.
Yeah, if you wouldn't mind putting on your mute, I would.
It's okay. Thanks.
Don't feel shy about jumping in either. But if you have metal flashing, it can be exposed to the elements. Most of the homes that we're talking about probably have aluminum metal flashing. Then there's another thing that's called exposed flashing, typically metal, and it could be exposed to sunlight. Then there's concealed flashing, which can be metal, but it's generally not metal. It's a rubber or plastic type material that's underneath and you can't see it. So just to give you an idea of these type of flashing materials, if you look at this picture, you see the metal flashing here, but then behind it, you see this black? This is a flashing also, but that's a rubber flashing that when you put the siding over here, then it is not exposed to sunlight. And I'll show you why rubber flashing is so critical to do the things that we need to do to keep our roofs leak-proof, especially with snow and ice sitting on them. But those are the two types of flashing materials that are used. What's the next part of the roof? The gutters and the downspouts. What do the gutters and downspouts do? The water falls out of the sky, it flows down from the roof from the top to the bottom, and then, were you able to see me writing on here? I hope you were, because I was writing all along and maybe you can't see it. But so the water flows down and it goes into the gutter, which is sloped, and then it comes to the downspout and it goes to the ground and it comes out at the bottom. So another very important part of a roofing system are the gutters and downspouts. Again, they work based on gravity. They need to flow from one end to the other and then go into a downspout. And their size, the size of the gutters, this comes up a lot. Where does the size of the gutters and downspouts come from? The local building codes tell you how much water you can assume hits your roof, and based on the area of the roof that goes into that gutter is what determines the size of the gutter to have the capacity to take that water away. So gutters and downspouts, we all know, are a very important part of the buildings, which I'm going to touch on. The other thing is, where do the downspouts discharge their water at the bottom? How many people here, and I can see you all shaking your head, how many people here have gutters and downspouts that dump the water right at the front entrance to the home or right in the driveway, where then in the winter, when the water comes out, it freezes and becomes a slipping hazard? Or how many people have, and you'll see some of the pictures, that based on the shape of the roof, you have such a small gutter and a huge amount of roof area that comes down into that gutter, so it shoots right over it because the gutter isn't big enough to handle the amount of water. So there's all kinds of things that happen with gutters and downspouts. The other thing I'll mention is if you look at the architectural drawings of buildings, in many, many instances, it shows the gutters. It doesn't show the size, and it doesn't show where the downspouts are supposed to dump the water. And it's left up to the imagination of the contractor. So gutters and downspouts, although they're not life-threatening unless you trip because of the ice, are something that can become a problem on your buildings. But gutters and downspouts are very other important part of the roofing system. Now let's talk about the attic. The attic is the area above the upper story of the home's ceiling and below the roof. So this is a typical attic in a condominium, as you all are aware, I'm sure. This is a limited common element. Just stepping back a second, the shingles on the roof, the gutters and downspouts are generally common elements, which means that everybody in the community can use them, or everybody in the community pays for the replacement as part of the reserve study. And it's the responsibility of the entire community. But in the attic is generally in the condo a limited common element, which means it's the responsibility of the association to maintain and replace if you need to, but it's for the individual exclusive use of just that individual homeowner that lives underneath it. Went off on a little tangent, but I'm sure everybody's pretty familiar with common and limited common elements are. But the attic, the purpose of the attic is to help control the temperature in the house, which I'll touch on a lot, by being properly ventilated. And in some cases, it's used for storage. Now, I've seen people use these attics where they sit on the floor of the attic right here. They put a piece of plywood or something and they store things in the attic. A general rule of thumb, if these beams you see at the bottom are 2x4s, if they're only 2x4 is actually 3.5 inches deep. But if those are 2x4s on the bottom of your attic, they are not designed to support storage. I've seen people do it, but it's really not designed for that. They have to be generally a minimum of a 2x6, not a 2x4 in order to put storage in the attic. So, but people do use these for storage, there's no question about it. Take a look at other things. You have wood trusses. The trusses hold up the roof, that's what these are. Now, what do you have? It's a piece of wood where at the top and at the bottom, it's connected with these metal plates. The metal plates are something that hold it together. It's made in a factory where they take the pieces of wood, they put them next to each other, and they put these plates, and then they put it through a press. So it runs through a press, which pushes these plates into the wood that hold the truss together. The reason I mention that is because I'm going to talk about water getting into attics. These plates are not meant to get wet. If they get wet, the wood gets soft and it can't hold these plates anymore. The plates have a tendency to pop out because the teeth can't be held by the wood anymore because it gets soft. So it's an important thing to understand about water getting into an attic and how it can potentially affect the structure of that attic. The other thing in the background, what do you see? You see this, let me see this more. Let me see if I can, in the back, you see this pipe that's coming up. This may be a dryer vent, it may be a bathroom vent or something, which I'm going to touch on because that, if it's not there, is putting a lot of warm air in the attic. The building code generally requires that these things have to go outside of the attic. They cannot discharge this warm air into the attic. But these are all the things that are going on in this attic. Now, what's missing from this attic? Anybody want to take a guess? Somebody must just look at the picture. What's missing? Anybody?
Insulation.
All right, who said that?
You got a double.
A double? All right, well, right down in here in between these floors, the floor beams, the 2x4s, 2x6, whatever, there should be insulation in here. Now, I'm hoping that this thing isn't finished being built, but there should be insulation in here. And it's missing, which I'll talk about as part of the presentation. You'll see it's very, very important. The other thing I'll say is, and I hate to be a structural engineer, but I'm going to be for a second. You see this in here, this is called a cord member. And then you see this bracing of the cord member down here. How many times do we see with the bracing, which should be put in the center of the truss, is put at the end of the truss? I mean, it really doesn't have to do with ice or snow on the roof, but for those of you structural engineers out there, if you don't have this in the center where it should be, these 2x4s can, under worst case scenario, buckle because there's not being laterally supported by this. And it looks like it might be here. It's hard to tell, but it looks like maybe that's it right here in the center. But so the structure is very important also. All right, so that's the attic. All right, this is what was missing, attic insulation. Attic insulation, and the attic is one of the most common places where heat loss can occur from the home in the winter. Now, keep in mind, and I'll mention it a few times as I go through the presentation, is that we're talking about the winter, and in the winter, you lose heat into the attic because heat rises and it can go through the insulation, which I'll talk about. But what happens in the summer? You can also get heat into the home and lose the cooling of your home if the attic isn't insulated also. So attic insulation keeps the heat in the home from rising into the attic and escaping, which I'll talk about a lot as part of the presentation. The other thing I'm going to point out, first of all, you see the floor of the attic is covered with insulation. But what are these guys over here? What are they? Those are called insulation baffles. And the reason they're critical, and I'll talk about as I keep going, is that right below here, at the end of the insulation is what's called the soffit that we talked about before. Now the soffit is, I'll show you on this picture, this part under here, under there, the name for that is soffit. That's where it sticks out a foot or so. The roof sticks out a foot or so from the face of the building. That's the soffit. So what's the soffit important for? ventilation because the air comes up through the soffit and into the attic, the nice cool air, which I'll talk about. But it's not uncommon for this insulation in the attic to be pushed all the way into that gap so the air can't get in. And it's not uncommon to see these guys, they're made out of styrofoam, they may be out of plywood, or not plywood, cardboard, but those are called insulation baffles. And the entire purpose of them is so that the air can get up through the soffit vent and into the attic without being blocked by the insulation on the floor of the attic. So that's the attic insulation. And you see the connection as I go on, that the attic and the roof is a system. It's not the individual parts, because the things that I'm talking about not only talk about heat loss with insulation, their ventilation, they're all tied together. Now let's talk about attic ventilation. Here's where I started a second ago. This is what it looks like. Here's the soffit, cool, fresh air entering the soffit vents, these soffit vents. And then at the top of the roof, you have a vent so the air can get out. Hot, humid air leaving the attic space. Now what happens is warm air rises, I said a few times. So when the warm air rises in the attic, and I'll talk about where it comes from, what it does is it draws the nice cool air in from the soffits as the warm air goes out of the ridge vent or other types of vents, which I'll touch on. So what does that do? In the winter, it keeps warmth out of the attic, which I'll talk about. And in the summer, it keeps warmth out of the attic. So it costs you a lot less to cool your house in the summer because the attic is nice and cool. The other thing here, as I mentioned, bathroom or kitchen exhaust fans. Here they are. These vents should exhaust out of the roof. How many times do you see it where these stop here in the attic and they just stop there and then they're pumping all the bathroom or the exhaust, all the warm air into the attic? That's a big no-no and a problem. The other thing we see is that, let me erase this. The other thing we see is that somebody will put a little vent on the attic here on the roof, and then they'll take this duct that's supposed to put all the warm air to the outside, and they'll just end it right here in the attic, thinking that air is going to go up and go out the vent. It doesn't happen. The air goes right into the attic. It doesn't go out. Don't fool yourself. The other thing we've seen is people take these vents, these ducts, and they extend them into the soffit, and they stop them here, and they think that this warm, moist air is going to go here and then go out the vents in the soffit. Other thing, it's not going to happen. First of all, the soffit vents are pulling in the cool air, which is going in the opposite direction. But as soon as this air comes out of this duct and hits any kind of resistance, it stops and it stays there. So this is how attic ventilation works. Let's see, did I miss anything? A warm attic in either season, is not good, exactly. So now let's not forget cathedral ceilings. A lot of homes have cathedral ceilings, and it's even harder for them to get to work, because here's how cathedral ceiling works when it comes to insulation. You have the ceiling here, and now what's right above the ceiling? You have the insulation that is above the ceiling in a cathedral ceiling. Now, let's say you have a 2x8 in here, a 2x8 ceiling joist that's 7.5 inches deep, and you need to have the soffit air come in, travel up above the insulation, and go out through the ridge vents. What do you think the chances of that happening are? How many times does that insulation go up and block the space? How many times do you see baffles in here? It's very rare. But let's see what makes it even worse. What happens if you have a skylight? You have a skylight in your cathedral ceiling like this, so the light can come in into your nice room up there. But then what about the air that's traveling up? It's totally blocked by the skylight. It can't get out. So cathedral ceilings, it's the same concept, the importance of ventilation, the importance of insulation. It's much harder to fix without taking it apart, as I'll talk about, but it's the same concept of insulation, ventilation, and all other things. I'll also mention another thing, whether it's a cathedral ceiling or not a cathedral ceiling. And what about if you put a recessed light here? What does that do? It puts a hole in the ceiling so warm air goes from the unit up into the ceiling. But I'm kind of jumping ahead, so that's a cathedral ceiling. So now, very important, as I mentioned before, the roof works as a system. It's not the individual parts. So what do you have? You have the shingles on the top. Then you have the flashing that we talked about. And here's one type of flashing that's a rubber membrane that I'll touch on, especially when it comes to ice damming. Then here, what do you have? You have the roofing paper. And what else is there? Attic insulation down here. You got insulation, attic ventilation. So you have to keep in mind that the roof system, the roof works as a system. It's not, unless they're all working properly, the whole system is not working. It's very important. So what does that look like? On the left here, winter conditions. This is an attic that's working, a functioning attic, we'll call it. So what happens is that you have insulation, and depending on the part of the country will determine how much insulation you have here. R50 is a certain thickness, but there's different types. But here you've got an attic that's functioning properly. You have the bathroom vent, the dryer vents vented directly outside. You have the attic floor penetrations are sealed, so the warm air can't get up there and the moisture air can't get up there. You have the air intake through the soffits, and you have the soffit baffles, what I call insulation baffles, the air gets in. And then the cool air circulates into the attic and it goes out through the ridge vent. Now what happens on the other side, a dysfunctional attic. You have the hot air and the moisture that comes up in the home. You know, you're cooking, you may have a humidifier in your home, so it's all rising. There's not enough insulation in the attic, it goes right through. And then I'll talk about what happens in terms of condensation, ice dams, block soffits, but that's all the bad stuff. So, but the thing you have to keep in mind is that the problems I'm talking about are caused by Mother Nature. Whether you have a perfectly built roof or not, it's not going to stop ice damming from occurring. If it snows and you get snow on your roof, it's from Mother Nature. You can address the potential for problems, but you'll never get rid of the cause. It's caused by Mother Nature. And I can't tell you how many times I've heard people say that there's a problem, my roof was designed wrong. Not thinking about that. That snow and ice is going to be there, even if your roof is built perfectly. So the problems are caused by Mother Nature. All right, the first thing, what are the problems? Ice damming. Now, ice dam is a ridge of ice that forms at the edge of the roof and prevents melting snow from draining off the roof, which I'll talk about. So here you got the edge of the roof and the water melts and drips down there. Now, I talked about before how it can be, problems can be accentuated by where the gutters are, how much roof area those gutters are taking the water off of, forgetting about ice damming, but just in general. Now, look at these roofs. You've got this huge upper roof up here. Then in the back, you have a valley. You have this dormer roof. In the back, you have a valley, and then you have a huge area roof up here. So in addition to this, this, and this, it all comes together and flows right through this little space. So you got a huge concentration of water coming down here. Do you think that's one of the reasons why I have so many icicles right in that right one spot here? Because there's a huge concentration. Look over here, same type of thing. Huge concentration of water that comes in that one area. But now it gets even more interesting. Do you think that this gutter that's along here that may be 8 or 9 feet long with one downspout that comes down has the capacity to carry away all this water? Well, the answer is it doesn't. So there's very special attention that in some cases need to be paid to where the size, the gutters and downspouts. But keep in mind, this type of roof configuration makes the building look nice. How many people would want a home that just has a straight roof all the way across that looks like a barrack? This is why it's built this way, to give the home a nice architectural features, but at the same time, it can cause some problems that can be taken care of as part of design. All right, so ice damming. Now, what causes ice damming? It's a 4-step process, which I've got here. Now, you're inside the home here. Indoor heat rises through the ceiling into the attic. It rises into the attic and warms the roof surface. Now you've got a roof surface here. This is the plywood of the roof. So what's happening? This roof surface is warm. Now, if I could just go back a second, because I want to point out here, I forgot to mention it. The best conditions for ice damming to occur is when there's snow on the roof, of course, and there's a long period of below freezing temperatures, especially if it's at night. Now think about, you got a lot of snow on the roof. At night, it's below freezing. During the day, it's above freezing. Or at night, it's below freezing. During the day, it's freezing. But you say to yourself, if you have all of that snow on the roof and it's below freezing, why do you have ice damming? So here's what happens. The heat from inside the home rises through the attic, and it rises, and what does it do? It touches the plywood that makes up the roof, the sheathing. It touches it and it warms it. So the temperature out here may be 20 degrees, but the temperature of the plywood here may be 40 degrees. So what happens at 32 degrees? Ice melts and snow melts. So the indoor heat rises through the ceiling into the attic and warms the roof surface. What's next? The snow on these heated parts of the roof melts. Now it's interesting because it melts from the bottom. It doesn't melt from the top because it melts underneath. If you got a foot of snow here, up here, maybe 20 degrees, but at the bottom where the snow is, the roof is 40 degrees. So the snow melts on the bottom. And what happens when it melts? It flows down the roof, it comes to the gutter, and as it goes down the roof, you don't have the indoor heat loss anymore warming the roof. It gets colder and colder. So down here by the gutter at the bottom of the roof, it's 20 degrees, temperature below 32 degrees. So the water that has melted flows down, goes into the gutter, and what does it do? It freezes. What does that create? It creates an ice dam because this gutter then backs up. It says snow in the heated part of the roof melts, flows down until it reaches the part of the roof that is below freezing, and refreezes into an ice dam. So now you have this cycle going on and on and on, and the temperature is below zero, and it keeps on melting and melting and melting because of the heat in the attic. So what happens? The ice dam continues to build. And what did I talk about before? A shingle roof is perfectly good for water if it's going down and over the laps, but now the water is going up and underneath the shingles, which is where the problems come in because the dam grows and moves upward under the shingles and it's fed from more and more melting snow above. So now once this water reaches the warmed roof surface up here, it's not freezing anymore. It will begin to leak into the attic and the home below because it gets under the shingles. Is everybody with me? Does anybody have any questions about this? Because this is ice damming and what causes it. And you can see that it's a catch-22 situation because up here it's warm, it melts, then it freezes, it starts going up, and now it starts and it's melted again as soon as it gets above. So the ice dam grows and grows to the point where it's at the roof area where the temperature of the roof is above freezing. And then what happens? It overflows and you get icicles. And like we saw in the last picture, the more concentration of water that's flowing into the one area, these icicles and the damming can be worse and worse, like we see in this picture. Now, how many people have communities that you see this in? I bet a lot of you do. So this is what causes it. That's the ice damming. Now, what's the result from ice damming? A couple of pictures. Bottom here, you get water in the attic. You can actually kind of see it here that the darker plywood here is wet. And then as you get up further, it's not wet, it's dry because the ice damming builds up to a certain level. To the right, it now drips down onto the insulation and gets to the ceiling. Up here, the weight of the ice hanging off the gutter's not strong enough to hold it, and the gutter may collapse. To the left here, you have a very large soffit here. Generally, they stick out a foot. This one looks like it sticks out a few feet. So the ice is now building up inside this area too. And the bottom of the soffit, this vinyl siding or vinyl cover here, falls off because of the weight of the ice inside of it. So these are the symptoms and of what happens from ice damming. So now, what do you look for? There's a typical types of snow patterns. And I'm going to show you what you want, but you'll never get it. Now let's start on the left. Right here, this is what a roof looks like right after the snow falls. You got snow all over the roof. This picture shows you have a home that all of the heat, let's go back to the picture where there was no insulation in the attic. So all of the heat goes directly up into the attic and melts all the snow quickly. So the snow goes away pretty quick because there's a lot of heat in the attic. Now, what do we have? Most modern homes, there's heat that goes in the attic. There's no question about it. So it's enough heat for the snow to melt and create ice dams, but it's not, but because there's heat. Now, this is what everybody you want, but you'll never get. The concept is to have a cold roof. A cold roof means that the attic temperature is the same temperature as the outside. So if you have a vent out here, like a gable end vent or vents in your attics, you should never block them thinking that you don't want the cold air to go in the winter. You want the inside of the attic to be as close to the outside temperature as possible, because what happens, we're going to come to the key word for getting continuing education units in a second, but what happens in this situation? The key word is called sublimation. Sublimation means that this snow that's sitting here doesn't melt and drip down the roof. It doesn't melt. Sublimation means it goes directly from a solid into a gas, and it's called sublimation. So the longer it sits there, theoretically, this kind of look you should have, it should be disappearing from the edges and not building up at the bottom. This is never going to happen. Now, you compare this, the word sublimation, by the way, I'm saying it a couple times because you're going to have to email that word to us, even if you don't remember what it means, to get your continuing education units. But this is what you want to have, what's called a cold roof. What's the opposite? What is a different type of sublimation? What is it called when a liquid goes into a gas? It's called evaporation. So this is solid into gas, water into a liquid into gas or vapor is evaporation. But this is the key word to get your continuing education unit. So write it down. Let's see, I have to chat. I have a couple of questions. Let's see. Is it? Somebody asked, is my mother's first name Neva? Actually, my sister is joining us for my mother's birthday today, so she's here, but I don't think my mother showed up. All right, so let's see. Let's see. Why doesn't the tar paper prevent the water from penetrating the roof wood and the siding? Great question. I'll tell you why. Because you can see this. You have the tar paper. The tar paper goes from the bottom of the roof, and it comes in certain widths, and it's lapped like this also. And sometimes you have tape on it, but it's lapped like this. You have a million nails that go through this. And once the water starts going uphill, there's always weaknesses within the building paper, in the roof, as well as on the siding, where water can get through. And I'll talk about how you kind of solve that problem, but that's why the water can get through still. All right, so now let's go to what are some of the aggravating factors? Inadequate ventilation. Now, if you have ventilation, so you have enough ventilation so you have a cold roof, it should get rid of the ice damming because the snow will turn into a vapor without melting. So the minimum required ventilation is not sufficient to prevent ice damming. I am convinced that you could put first of all, the building code does not say to put in enough ventilation to get rid of ice damming. There's minimum requirements, but if you have a lot of snow on your roof, it's not going away just because you have a lot of ventilation. But you can never have too much ventilation, and ventilation must be looked at together with improper insulation. So one of the aggravating factors that's not going to make it go away, but can make the conditions better, is a lot of ventilation. All right, improper attic insulation. We've talked about this a few times. Not enough is installed, or there's joints between it, and there's voids, there's thin spots. And the one place where I see a weakness on a lot of buildings is where you have recessed lightings in the ceiling on the top floor where the warm air can go right through and into the attic, or you have an attic access hatch into your attic. How many people put insulation on the back of their attic access hatch? A lot of people don't do it, so that actually creates a hole in your ceiling so the warm air can get into the attic. Also, you see here uninsulated flue and dryer vents, pipes, or equipment in the attic. And this generates heat in the attic because there's warm air going through this, but it may not be insulated. So because of that, it's giving off heat in the attic. So improper attic ventilation. Now let's talk about condensation as another problem where we all pretty much get it in regards to ice damming. What's another problem? Here's a picture. What happens? In the summer, you're sitting out by the swimming pool, you have a glass of cold water. The warm, moist air touches the glass, the cold glass, and what does it do? It condenses, and you get liquid all out on the outside of the glass from condensation. That's because if the warm air, moist air touches material that is below the dew point, The dew point is the temperature where the moisture in the air will turn into a liquid. So if the glass is below the dew point and the warm, moist air touches it, you're going to get condensation. So what happens in an attic? Here you go. You've got the same thing. You've got warm air, moist air coming up from the house. And then you have, in this case, you have sheathing that it doesn't have to be below freezing. The dew point could be above freezing. So the warm, moist air touches the sheathing and condenses. So you get condensation in your attics. Believe it or not, I've been in attics where it looks like it's rained. You've got so much condensation because it turns into a liquid on the sheathing and then starts dripping down into the insulation and into the units. Plywood does have a tendency to absorb a slight amount of moisture, but still condensation is not an uncommon problem in attics. So when moist air enters the attic from dryer vents, bathroom vents, a humidifier in the home. How many people have seen a humidifier in the home where it puts so much moist air into the home that when the air in the home touches a window, you get condensation because there's so much moisture in the air. So what results in water in sheathing, rain in attic, and the other thing you can see, you don't have to see it when it's happening, but if you go into your attic and there are roofing nails that come through the roof sheathing that hold the shingles in place, if you look at the tips of those nails and they are rusted, that means that you've had most likely had condensation in your attic, because just look at the roofing nails because they rust. So condensation, another important problem. So what are some of the other problem areas? Chimneys and when you have walls. It's not ice damming, but it's snow sitting on the wall. And I talked about before, here's what it looks like. Now you have snow that sticks up about 5 inches. This step flashing goes up 5 inches, so the water gets behind the siding and behind the flashes. That's a common type of flashing that you have wherever there's a wall, whether it's a wall or a chimney. A chimney is essentially a wall. So that's some other problem areas. Another area is valleys. These valleys, when you have two roofs come together, they create a valley. You all know what it is, and it has a tendency to be much shallower slope than the rest of the roof. So ice and snow have a tendency to build up here. Now, believe it or not, we make things worse because what was happening on this roof was there's a concentration of water that's coming down. This may be right over the front door to the house. So what happens? The water shoots over the gutter because it's not big enough. And whenever it rains, you get water shooting down to the main entrance of the house. So what do? They put in this flashing. You see this flashing? This flashing is to divert the water to the sides rather than right down at the edge. But what does it also do? It traps the water when it's melting from underneath like an ice dam. So you have much higher buildup here because you have something like a gutter that's trapping it by this flash. Not uncommon to put these in. I call them rain diverters. You see them on a lot of roofs to divert the rain so it's not going to places you don't want it to go. Short-term solutions, I'll tell you, there aren't any, but I'll throw some up here because none of you are going to do this. Remove the gutters. You're not going to remove the gutters because if you remove the gutters, they're going to damage the building. Imagine going to a roof that the gutter is filled with ice and you've got the icicles that are sticking down 3 feet and those gutters are attached to the building. Are you going to remove the gutters? Because what's happening is that ice has frozen the gutters to the shingles. So if you pull the gutters down, you're pulling the shingles off too. The other thing to keep in mind also, which I'll show you in the next picture, is just because the gutters are gone doesn't mean you can't have ice damming. You can't have ice damming even without gutters, but you're not going to remove the gutters. Are you going to remove the snow? Are you going to have somebody go up on your roof and start shoveling the snow off? First of all, you're going to have to take all the snow off the roof, which you're not going to be able to do. Second of all, it's very dangerous. Third of all, as soon as you start shoveling the shingles, you're going to damage the shingles and your warranties are going to be gone. So removing snow from the roof, you could talk about it, but it's very, very dangerous. It's not done. Now, I just want to mention that here's a picture. You take the gutter off. Now look, you have a large soffit, so it's freezing here below here. So the ice dam starts forming as soon as it gets below zero. It doesn't have to be at the gutter. So the ice damming can start up here rather than at the gutter. So if you think that taking the gutters off, it's going to solve your ice damming problem, it may not necessarily do that. Some other solutions. What about snow ice devices, snow melt devices? You've seen them, you put wire, maybe you've seen them, you put wires up and down, and what it does is it melts the snow down by the gutters. Now that may let the gutters be clear of ice so the water can flow, but like I mentioned a second ago, it's not going to stop the ice damming because it can happen up further. So then the other question, in a condo, where are you plugging these into? Whose unit are you going to plug these snow melt devices into? It's very rare that you see these. I have seen them, but it's very rare that you see them used. And I put them down as long-term ice dam solutions, but I'm going to get into the long-term ice dam solutions, but this is really a medium-term solution because you can do that before the winter season without doing anything to the roof. You just nail these onto the shingles. So that's one thing you can do. So what do? The first thing you have to do is determine the source of the heat and moisture. Now this stuff, by the way, everybody,
I'm always through with it.
if you wouldn't mind putting yourself on mute, we're going to send a copy of the
It's very easy. As long as you're not a criminal, if you don't have a criminal record, it's
Yeah, somebody,
you
there's somebody
go
talking.
to your county that you live in. I think it's through one of the representatives. Just look it up online. You fill out the paperwork, you
Oh, yeah,
mail them $2,500.
Here, you're all muted, it worked. Okay, so these are some of the places where common attic air leaks where it comes in. Exterior wall supply grill, we talked about this, attic access hatch, interior wall, top plate, return grill, recessed lighting, low insulation levels. These are some of the things that cause the heat and moisture to get into the attic. The other thing I want to point out is, in many instances, you may have ductwork in your attic. A lot of homes have ductwork that pumps the warm air to the different parts of the house. Leaky ducts puts a lot of warm air into attics, which accentuates ice damming in big time. It can make a big problem. We're actually working with a community right now that's going through transition, and they've had ice damming problems that are significant. And one of the things we found is that the ductwork in the attic is not taped properly and is giving off a lot of warm into the air into the attic, which is not going to stop the ice damming, but it's going to minimize the amount of ice damming you're going to have. So leaky ducts is a source of heat and moisture into the attic. So what do? You want to seal the attic. You want to add the insulation baffles. You want to put in proper insulation levels. You want to seal all the ductwork, and it's all the things I talked about, which will improve the ventilation and the insulation in the attic. So another way, ventilation, there's a few different types of vent I want to point out. First, I'll show you this right here is what comes out of the building code. It says the minimum net-free ventilating area should be 1/150th of the air of the vented space. So if the area is 150 square feet, you need 1 square foot of venting to provide the code-required ventilation in that attic. Then there's an exception. It says if you put venting at both the top and the bottom of the attic, then you can reduce that to 1/300th, not 1/150. Just want to point that out. Again, it's not enough ventilation to stop ice damming. Now, this picture is a typical ridge vent. You see the top of the ridge. This vent is what I call a square vent. It's a passive vent where the air comes in the attic, from the attic rises and comes out. A ridge vent, it comes to ridge and comes out. Over here, I show the attic, the insulation baffles again. I want to show this also. This is a powered ventilating fan. Now, a lot of people think that a powered ventilating fan is used in the summer so that when your attic heats up, it turns on based on the temperature and pulls all the hot air out of the attic. There's no question that does that. It makes a significant difference in the amount of heat on the top floor of your home. So if you're single zone air conditioning in a 2-level home or a 3-level home, you need these attic ventilators. You probably can't sleep upstairs. But the thing I want to mention is you can get these attic ventilators with what are called humidistats in them. And the humidistats will turn on the fan depending on the humidity level in the attic in the winter to draw the humid air out of the attic, which will help with condensation problems. So it costs such a little amount more to put a humidistat on your attic ventilators. I would suggest if you're replacing fans or putting in fans, you have them with the humidistats so that they control the moisture also. Another long-term solutions. Now, the long-term solutions I'm going to show you now should be done as part of a roofing project. When you're doing a roofing project, it costs so little to add these additional things that you should definitely include in the scope of work. Here, down at the bottom, This is where you have the ice damming. The ice builds up, goes under the shingles, and gets into the unit. This is what's called E-flashing. It's a rubber membrane that comes in 3-foot rolls, and it extends up from the gutter line so that even if the ice and snow builds up and gets underneath the shingles, there's much less chance of it getting into the attic because you have a rubber membrane here that the nails that go through it are self-sealing. It glues down to the roof so it even can go on top of, well, there's shingle nails are going to go through it, but it's self-sealing. This makes a big difference. We've seen some communities where they'll go up more than 3 feet. They may use 2 layers levels and maybe go up 6 feet or go up 4.5 feet, but huge difference. The other place is where you have valleys. These rolls come in 3-foot wide widths of this rubber membrane. They stick down, put them there so they go 1.5 feet on each side of each valley. Here you have vertical walls. At these vertical walls, not only put in the step flashing, the metal flashing, but put in this rubber membrane so it extends 1.5 feet on the roof and 1.5 feet up the wall. And it'll be significant in terms of preventing ice and snow from getting in there from snow drifts against the walls in your buildings. Keep in mind what I said before, that all the flashing has to be installed in such a way that it sheds water to the outside, not to the inside. So there's all kinds of other things that need to be put in here, right? But these are the things that you should put in at a minimum when you're doing a roof replacement project. Also at the edges here, this is a rake edge, this is an eve edge. Typically there's a piece of a drip edge that's put here that's metal to close off any openings, and that's part of the roofing system. But a long-term solution is this type of thing does not add a lot of money to your roof replacement project. It should be included. Here's an example of what I was talking about here. This on the bottom, this is what I talked about, the step flashing, but I would have in here that rubber membrane that goes 1.5 feet onto the roof and 1.5 feet up to a wall to keep the water from getting in behind the step flashing. And then, of course, the building paper has to go over it to shed the water to the outside, not to the inside. Makes a big difference. Same thing here, this type of roof. Anytime you have an intersection, put the rubber membrane up and along the roof and up the wall. Makes a big difference. I do want to point this out because we hear this terminology all the time, and it's called kick-out flashing. Do you have them? If the water's coming down the roof like this and the roof ends within a wall, you need to have what's called kick-out flashing so that the water comes down and goes into the gutter. If you look at your buildings and this kick-out flashing, which you can see is not there, what's happening is the water's coming down, it's not going into the gutter, it's going behind the siding, and there's a very good chance you're getting water damage right as part of your house. Kick-out flashing they cost $0.05 each probably, and they're missing in a lot of different places. So keep in mind kick-out flashing. Now, in summary of my presentation, which I'm right on time, the conditions we talk about to minimize roof system problems in the winter also work in all seasons. So in the winter, it saves on heating costs, prevents leaking. In the summer, it saves on cooling costs. So it's an all season thing. There really aren't that many, if any, short-term solutions. If you increase the ventilation, if you increase the insulation, it's not going to stop the ice and snow. It may reduce slightly the amount of ice damming. The real way to solve the problem is when you re-roof your community and you do the type of things I've spoken about. So now I'd just like to thank you. And I also, you see here, I said, and thank you to Google Chrome. I have so many diagrams in here that I would do a web search, get some great information, some great sketches. Like these sketches that you see here, these guys, these come from Energy Star website. There's so much great information out there. So now what I'm going to do is I'm going to open it up. I stop share. I'm somewhere around here and open it up. If anybody has any questions about anything, please jump in, chat, and I'd be more than happy to try and answer any question, even if I don't know the answer. So does anybody have any questions about this?
I just needed to know what the secret code is for today. I got bumped off for a minute.
Oh, so you're here for the credits, not for the information.
Oh, no, the information was great because I'm dealing with roof issues right now. Thank you so much for the information, but I don't want to miss out on my credit either.
Okay, I just put it in the chat. It's sublimate. But what does it mean? What does sublimate mean? Anybody want to give it a shot? No, I'm just kidding. Anybody else have any questions about anything? Any comments? Like I said, I'd be more than happy to try and answer them. No? I see somebody from American Pool. What do you have to do with roofs? Is that a rooftop swimming pool? Is that what you're here for?
I like learning about different systems, and yeah, rooftop pools. We have there can be challenges where you've got runoff on the roof that can wherever there's water and we're involved, they usually they point to the pool. So it's just good to know how this stuff works.
All right. So anybody have any suggestions? My mother didn't show up, and it's her birthday. She said she's showing up for her birthday tomorrow, and she's not here. I'm gonna have to send her the recording. All right, here it says one question: should rake boards be sealed? I think that was the question. Let's see. Should rake boards be sealed to help this? Good question. On the rake board, that's at the edge where the roof comes over, and then there's a vertical wall. That wall is called the rake end of the roof. And right where the roof intersects with that wall, you got plywood that comes over, and then a wall that comes down. Typically, there is a drip edge that's put there, a little piece of metal that goes over. In some cases, people will take 1.5 feet of the rubber membrane and put it that rake edge. It doesn't hurt. The only comment I'll make about rubber membranes, because I've heard people in some cases where they'll take a low roof, a small roof, and they'll cover the entire thing with roof membrane. What does that do? It can make your condensation problems worse because then it's trapping all the moisture in the attic. It can't get out. The plywood breathes, the rubber doesn't, so it holds all the moisture in. So I warn people, use the rubber membranes the way you should, but don't cover the whole roofs with them because I think it's going to create a ventilation problem. How do you properly seal recessed lighting? It's a good question. You'll have to look at the manufacturer's literature, and some recessed lighting, if you look at it, is made to go in an attic space so that you can actually put insulation and flash right up against it, not against moisture, but of course against airflow. But you have to be very careful to make sure that you're dealing with non-combustible materials when you're dealing with recessed lights. And if anybody has any thoughts, it can be done. I doubt if it's going to be done if you bought a home with a bunch of recessed lights, unless they put in nice lights. But it's a great point because those recessed lights are just putting holes in the wall. Mitch there's a Neva Frumkin on. That's my sister. This is a family outing tonight. So only be nice to me. So, but recessed lights are a tough one. It's a tough one. So are fire or what do you call skylights and these kind of things. But the recessed lights put holes in your ceiling. Any other thoughts? What are the pros and cons of putting a metal drip guard over the entranceways of a commercial building? Over the entranceways at a commercial building as far as ice dams. Ice dams are, as far as ice dams, first of all, they're typically created by sloped roofs. I mean, so I don't know if the commercial building, just because it's a commercial building, not a residential building, if it has a sloped roof, it will probably get ice damage because that's snow and ice on the roof. So the metal drip, the eave flashing, the rubber membranes, all those things I'm talking about are not just limited to residential construction. Like I tell people, a building is a building. It doesn't care what you use the building for. Mother Nature is going to affect it in the same way. Should vent pipes and attics for bathrooms be insulated? If they can, I would, and they, very important, vented to the outside. Any type of heat that's given off in the attic will create the type of problems I'm talking about. So if you can make them insulated, I would say yes. Can you touch on slate roofs? Slate roofs are basically the same thing. I mean, they're lapped going down the roof. They're very heavy, as you know, and they work in the same way. They have a much longer useful life than a shingle roof, as you would anticipate. But I don't see why you would not have ice damming problems with a slate roof as well as with just a regular shingle roof. Any concerns using salt blocks, scupper boxes, flat roof? Salt is used generically. You have to make sure that the material that you use, I call it an ice melt material. Use materials that don't react with the metals, the shingles, because it can void warranties. I mean, How many times have you seen salt used on sidewalks to stop the icing and then it deteriorates the concrete? So you have to be very careful what you use so it doesn't affect the materials it's sitting on. Any other questions? No, come on. We still have 54 people here. This is a pretty good turnout. If anybody, by the way, if anybody has any thoughts about any upcoming webinars you'd like to have, as you know, we do a lot of reserve studies, roof replacements, just about anything. I think the timing was right for this one because it's getting cold. I think this weekend it's supposed to be 10 degrees and we might be getting snow. So I hate to say it, but it's too late for you to fix it for this year. Other than if you have a rubber membrane, something there. Let's see. Is having gable vents, turbine power vents, and baffles remove too much venting? Again, I don't think there's ever too much venting. Get the cold in there. When you talk about turbine vents are generally the ones that sit up, that when the wind blows, they turn on the inside and they suck the air out. So there's so many different vents you can have, and I'm not opposed to having a lot of venting, that's for sure. If anybody has any questions about anything, feel free to reach out to us. If you ever have something in your community that's related to roof or anything else you want us to take a look at, just send us a picture. Easiest way to insulate the attic entry hatch. Take some blanket insulation, I would say, and just go up into the attic and lay it down on top of it. And then you have to they sell sealant strips to put around the outside, because even if you put the insulation on it, the air is looking for the path of least resistance and it'll go up through the little gaps. So you should put not only the insulation, but put a little sealant strip around it. If you walk into Home Depot and ask the person who's standing right at the front, they know where everything is. They'll tell you exactly what aisle, they'll tell you exactly what to get. And just tell them you want to insulate your attic access hatch and they'll tell you exactly what to do. It gets harder if you have an attic access hatch that has a ladder attached to it, because you've seen them also where you pull them down and there's a ladder. Those are harder to insulate because the ladder gets in the way, but there are ways to do it. So anything else? All right, well, thank you all very much for joining us. This is recorded, so I don't, Jolie from my office who's here somewhere could probably tell you where it's recorded. And everybody who's here, if you'd like to have continuing education unit certificate, just send us an email with the famous word sublimate, and we'll send you out a certificate. And we'll also send you a copy of this PowerPoint presentation. Feel free to share it. If you'd ever like us to give this presentation, for example, to your management company individually or to your firm, we'd be happy to do that also. And if you want us to, not that this is a commercial, but if you ever want us to come out at your community to look at it in terms of getting involved in putting together a specification for your roof replacement, our roof replacement specs include all of this kind of stuff to prevent against ice damming, to look at the insulation, the whole thing. All right, everybody, thank you very much. Have a great day. This is odd. Usually the audience disappears from all study. All right, thank you very much, everybody. I really appreciate it. Have a great day, and be safe. It's crazy out there. All right, take care.
Thanks, Mitch.
Thank you.
Thanks, Mitch.
Thanks,
Well
Mitch.
done. Thank you.
Thank
You're very good.
Thank
Great
you.
job.
Thank you very much. Have a great day.
Thank you.
You too. Thank you.
you.